In this video, we'll talk about some of the limitations of representing numbers using computers. In CSC 108, we've occasionally seen some strange things happen with numbers of type float. So far, we've told you you don't have to worry about those. Now, we're going to take a closer look at this behavior and discuss what we need to do about it within the context of the course. First, just note that the behaviors we're going to talk about have more complicated explanations than we'll be able to address in this course. If you're very interested in the idea of representing numbers in computers, then there are third-year computer science courses that you can take that take a much deeper look at this. So here's an example like something you may have seen already in the course. I'm going to divide 7 by 3. Our result is almost correct, but not quite. You would expect to see 2 followed by an infinite number of 3's, or at least some indication that the 3's repeat forever. Instead, we see a finite number of digits, and most interestingly, the last digit is 5, not 3. So what's going on here? To begin to understand this, we need to think a little bit about how numbers are represented in computers. You may have heard terms like 32-bit or 64-bit when referring to computer memory. This is because computer memory is made up of millions or billions of bits, which are a very simple storage unit that can be 0 or 1. All information stored in computer memory is actually stored using bits, although the details of how that works are far beyond the scope of this course. The key takeaway for us when it comes to representing numbers is that even though computers have very, very large amounts of memory these days, it is still not infinite. And as you know from math, the number of real numbers is infinite. So the real issue with representing numbers in computers is that computers have a finite amount of memory with which they are trying to represent an infinite number of values. In practice, for us as Python programmers, this means that sometimes we will see some small imprecisions in the numbers we're working with. For our purposes in this course, we'll see that these imprecisions are usually very small and do not impact the kinds of mathematical operations we need to do. However, we will see some interesting things happen when we work with floats, especially when we try to compare them to each other. Let's take a look at another example now. We already saw that 7 divided by 3 gives us a result that isn't quite correct. What happens if we try to compare that number to what we think the right answer should be? So I've typed out far more 3's after the decimal than what we had originally. So you can see, looking at these numbers, that what Python gave when evaluating 7 divided by 3 and what I've typed out here are different. But it actually returns true, even though you can see that these two numbers are different. So why are they the same? Let's take a look at what Python says the number we typed is equal to. Remember that when we put in an expression in the Python shell, it will evaluate whatever that expression is. So Python actually is not able to represent that number exactly as we gave it. And we see the same imprecision we saw just dividing 7 by 3.